I have got 6 p.m. on my end. How about you, Dan?
Yep, we got 6 p.m. here. And just wanted to check, can you hear us in the room a little better?
Yes, I can. Much better.
Okay, great.
Thanks. All right, let's go ahead and get started. First and foremost, I want to thank everybody who is tuning in for taking time out of your schedule to come to this webinar. I really appreciate it. I'm hoping that everybody is interested in the work that we've been doing so far on the North Carolina blue crab stock assessment. And I'm sure there are other things you would rather be doing with your evening. So again, I just want to voice my appreciation for you being here this evening. So I want to start by talking about why we're here tonight. So first of all, many of you, I'm sure, have not seen me before. You haven't talked with me, although I see some of the names of participants, and I know you have. But we're a relatively new stock assessment program in terms of staff here at NCDMF. And we're really trying to pursue some new approaches when it comes to stock assessment, but also as it comes to engaging with the public as we work our way through it. So this is really meant to be a first step. We're really interested in, can folks hear me? I saw a chat go in to turn up the volume. Can I just get like a thumbs up from the folks online, like if they can hear me nice and clear? Okay. Okay. I mean, I'm seeing some thumbs ups and some hands up, so hopefully folks can hear me. I'm trying to speak at full volume here. So anyways, this is really meant to be a first step. We're interested in creating more opportunity for the public to engage with the stock assessment process. The whole reason that I'm here tonight is because a member of the fishing community came to me and said, hey, we're only able to engage with the stock assessment process when it's basically already done. So the only part of the stock assessment process that's historically been open to the public is the peer review, which happens at the end after the stock assessment is built, and a lot of the conversation is happening at a really high technical level. And so I learned about this several months into my now short tenure with DMF, but I'm very interested in doing more public engagement and being transparent about the work that we're doing within the stock assessment program. Um, so one thing I saw a lot online and heard from some folks I talked to on the phone is they were worried about this being a place where we're going to announce new management or new restrictions on blue crab. And this is very much not that. As far as my end of things, this is a purely informational session, but ultimately it's about me wanting to get feedback from you after showing you some of our work. So there's not going to be any kind of new management. We're not talking about implementing anything new as it comes to blue crab tonight. So I just want to get that out of the way. Hopefully, folks are letting out a sigh of relief. And I also want to say we're not done with the stock assessment. This is really kind of a midpoint check-in, and so this is really all about wanting to show our work and hear what you think. So here is what I plan on going over tonight. First, I'm going to go through some background. I don't want to assume everybody on this call knows everything about stock assessment, so I want to go over who we are in the stock assessment program, what we do, why we do it, and a little bit about how it's done. Ultimately, I really want everybody to be able to follow along. I'm not trying to pull a fast one on anybody, so I'm going to be defining all of the words that are specific to stock assessment so that everybody can keep up. Next, I'm going to talk about the peer review of the 2023 North Carolina Blue Crab Update Assessment. This has come up in a lot of conversations, and I would like to address what happened exactly and how it has led to the approach we're taking with this new stock assessment. Then I'm going to go over the information or data that we've been reviewing and analyzing for the 2026 North Carolina Blue Crab Benchmark Stock Assessment. Walk you through how we did what we did and why, give you some rationale. And then finally, I'm going to give a short description of the model that we are going to use. I am not going to get into a ton of specifics or technical details about it, but I do want to talk to you about which model we've chosen and how it works. So I'm going to start with a plan for tonight and a code of conduct. So we have a lot of information to share and get through, but we also want to hear from you. So we're going to have to be really tactical with our time. What I am aiming for is about 60 minutes of us on the DMF end talking, and about 60 minutes of us talking with you. To that effect, I'm going to pause the presentation 4 times tonight to have a 15-minute question and answer or question and comment session. So I want to lay down some ground rules. Please be respectful with your questions and comments. Some of you know me and you know me to be a reasonable person. Some of you don't know me, and I'm hoping that we can get to know each other a bit on this call and keep the dialogue going after this call is over. Then I also want to ask that folks be on topic with questions and comments. One thing I will point out when I talk about our stock assessment program is we are the scientists. We are engaged in mostly research and model building. We don't make management decisions. We don't make policy decisions. At the very most, we may give some advice based on the results of a stock assessment about what management we think would be effective in terms of achieving goals, either for conservation or for the fisheries themselves. But in general, my realm is that of research. And so since we're using a webinar to do this, I ask that you use the raise hand feature. If everybody's layout looks about how mine does, there should be a raise hand in the center of the bottom on your panel. So go ahead and use that. And it's going to be kind of a first come, first serve situation. So I will try to address questions and comments as they come, but we're going to try to keep it tight to 15 minutes to each of those sessions. So that way we can get through everything within the 2 hours we have. We're going to aim for a hard stop at 8 p.m. tonight. Because like I said, I'm sure a lot of you would rather be doing something else. So please wait until we pause the presentation to ask a question or put a comment in the chat. And that's it for the code of conduct. So I'm going to go ahead and introduce our staff, which isn't going to take very long because there's only 2 of us. So here is me, a much happier guy in 2019, holding this handsome cobia. My name is Matt Damiano. I have been with NCDMF just under a year, about 11 months now. Before that, I got my PhD at North Carolina State University. I actually did it here in Morehead City with Dr. Jay Chow over at the Center for Marine Science and Technology. Before that, I got my master's from the University of Maryland, where I worked with Mike Wilberg. I used to be a stock assessment analyst for NOAA. I worked for the Caribbean Fisheries Branch, so I have quite a bit of experience working in a range of data limited to data rich conditions for fin fishes and invertebrates. So I've worked with red snapper, dolphin fish, spiny lobster, oysters. And then before I worked for NOAA and before I got my PhD, I used to be a groundfish biologist for the Northwest Indian Fisheries Commission out in Washington State. So now that I worked for the state of North Carolina, I've kind of completed the trifecta of working for every level of government, which may or may not be a good thing depending on your perspective. I'm also adjunct and external research faculty at a couple of universities. I have mentored students at College of Charleston and University of Maine. And I already spoke to that last bullet point. So keeping things moving, our other member is Dr. Matt Zink. He joined the same day as me, so our program is not only new, we've been building it from the ground up together. He got his PhD right before he joined DMF in 2025 from Louisiana State University, and he got his Master's of Science from Michigan State which has a great quantitative science program for stock assessment in particular. He's also studied macro-scale stream fish ecology, so he's got a really interesting background and an interesting skill set that's proven really useful to us so far. He's also done stock assessments for Lake Huron, Atlantic salmon, and he loves fishing and is quite a bit better at it than I am. I am not afraid to admit that. So before I jump into anything else, I want to start with some stock assessment jargon. So some terms that I'm going to be using throughout the presentation. The first is really what stock assessment, what stock assessment is all about, which is the study of population dynamics, measuring population dynamics. And that is the study of measuring animals' vital rates. So every animal is born, it grows, it survives over a period of time, and it dies. Population dynamics is all about measuring these things at a population level. So kind of treating the population as a mega organism and studying these rates. So a population, at least from our perspective, is just a group of individuals that are part of the same species that can interbreed and exist within the same area and at the same time. This is kind of the traditional ecological definition of a population. But a stock and a population are not always the same thing. Ideally, they would be synonymous, but it can be different due to management boundaries or politics. So I have a couple of examples here. The first is southern flounder. So if we were to consider all the southern flounder that are just within North Carolina waters, either the estuary or the open ocean, we could call that the North Carolina southern flounder stock, but that would not be the same as the southeast southern flounder population, which extends from the Virginia, North Carolina border down to Florida. Another example are the two red snapper stocks in the southeast US. There's the South Atlantic red snapper stock and the Gulf red snapper stock. And in this particular case, they are genetically distinct, so they are separate populations. All of which is to say that the difference between what a population and a stock is can be confusing and frustrating. And then finally, a fishery. I assume everybody knows what this means, but I'm putting this up here just in case. It really just refers to the removal of an aquatic animal, either for commercial, recreational, or subsistence purposes. And this includes fish and shellfish, which are the main focus in North Carolina, but can also include things like birds and frogs. There are bullfrog fisheries. There's a cormorant fishery in Japan and one that might open in Europe, for example. Oops. And I've got one more here, which is data. I'm going to use this word constantly. And this really just refers to information that's collected in a systematic or statistical way. And I'll get more into what that term statistical means later on. So what is a stock assessment? Ultimately, a stock assessment is a model. So that's great, but what's a model? A model is, in our line of work, a mathematical representation of a natural system where fisheries and fisheries management occur. So it's a mathematical representation of the population biology of the stock, the fisheries that fish them, and then how fisheries management affects that fishing activity and the biology of the animal. It's ultimately going to be a simplification of reality. I've had some really interesting conversations about specifics relating to different fisheries that we couldn't possibly model because we just don't have the data for it. And so there is nuance that gets lost. I want to acknowledge that up front, but this is a simplification that we really can't avoid. It's kind of a necessary evil in this line of work in order to be able to measure things at a population level. And so I really like this quote by the famous statistician George Box, which is all models are wrong, but some are useful. And so the goal of stock assessment is really to build useful models, not just, slightly wrong models. And interestingly, if you read up on the history of stock assessment as a field of study, it only really exists because fishermen approached scientists in the late 19th century and asked why fish populations were changing from year to year. And this led into an investigation of recruitment dynamics. So how many fish were added to the population each year and why it wasn't the same from year to year. So what exactly does a stock assessment model do? So let's take our favorite fish, southern flounder, and pretend we have a population made up of a bunch of fish of different sizes and different ages. So we try to model this population and then also how new fish, or recruitment, it's often called, are added to the population each year or each season within a year. Then we also try to model the growth of the fish, because fish, of course, grow over time, as do invertebrates like crustaceans. And if there is movement and we have information on movement, we try to consider this in the stock assessment model as well. We also need to model death, either from natural causes or death from fishing. And then we also need to model any changes in management that might have affected fishing activity. And so fundamentally, at a bird's eye view level, this is what a stock assessment is trying to do. It's simplifying a whole lot about an animal's biology, but that is part of what makes these kinds of models work. And so how does it work exactly? So I want to state up front that we can count some fish, and I'll say the other part of this momentarily. And so NCDMF collects data from both fisheries directly and via scientific or statistical surveys in our waters. This is fundamentally how we're able to observe the natural system. You know, fish and crab are hard to count one by one, and so getting these kinds of data or statistics is really the best way that we can make observations about what's happening. And so what stock assessments then do is use those mathematical representations to describe this natural system, but then it also contains a statistical model which uses statistics to fit what the model is predicting to the observed data. So basically, the stock assessment is trying to get its predictions to match our observations so that reality can be essentially like agreed upon by the math and by what data we collect. And so what we do is we try to integrate as many of these observations as possible, and with statistics, we estimate the population quantities that we need in order to come up with goalposts for managing a fishery. And so this tends to be things like the number of fish that there are or how hard you can fish. More on this momentarily. So this begs the question, why do we do stock assessments? So I really like this quote by the marine biologist John Shepard, which is managing fisheries is hard. It's like managing a forest in which the trees are invisible and keep moving around. I couldn't agree more. It is a difficult task, and I wouldn't wish my job on my worst enemies, but I do love it. We can't count every fish. We can count some fish, but we can't count all of them. And that's where statistics becomes our most powerful tool. We need statistics in order to estimate what we cannot see. And so surveys, the scientific surveys in particular, need that statistical design in order for the models built for statistics to estimate population level quantities. And so we often get asked, why are we sampling in certain areas where we know or we've heard there aren't an abundance of fish or crab? And it has to do with that random or systematic sampling necessary to make these models make sense of those data. And so I mentioned before that we also need to measure the effect that fishing has on a population. It may not have much depending on what the animal's biology is, but it's an important feature and really one of the main reasons we do stock assessments. The one thing stock assessments do better than any other model out there is measure the effect of fishing. And so the results from the stock assessment form the cornerstone of fisheries management and related harvest policies. So for those of you familiar with the Magnuson-Stevens Act, which just had its 50th anniversary, or the North Carolina Fisheries Reform Act, you need results from a stock assessment in many cases to make determinations about how the population is actually doing. And so we call this determination, or we call the values we use in the determination stock status. And so these are used to trigger management action. And so I mentioned before that these are mainly the estimates of the size of the population. So how many of the animal there are in number or weight, or how many spawning individuals there are, so animals that are actively reproducing, and then how hard fishing has been. And I'll talk more about that in a bit. So let's talk about NCDMF's stock assessment process, both as it was and as I would like it to be. So traditionally, there are 4 or really 5 steps. There's the planning and the data review stage, where we do a review of the quality and quantity of available data. We try to chase down every thread on possible information that there is and determine whether we can use it in a stock assessment. And stock assessments do require certain features of the data. And so that's a determination that the stock assessment analysts in the program ultimately have to make. Can it be used? Is there enough information there that it's going to give the model useful information? And then once we've gone through that part, we try to determine what model is going to make sense given the data. I am seeing the comments about the volume being really quiet, and I apologize for that. I am trying to speak as loudly as I can, and I've gotten a bunch of thumbs up from other folks, so I apologize for those technical difficulties. So ultimately, which model we're going to use is wholly dependent on the data. If you don't have a lot of data, there are models that are considered data limited that you might want to consider. But if you have a fairly large amount of data, there are more complex data rich stock assessments we can use to try and leverage all of those data. Once we've done the methods review and decide on what model we're going to use, we may need to do some additional model fitting. This is usually to try and do what we call standardization of the survey data, sometimes also the fishery data. Essentially, there's a lot of noise in data that can sometimes interfere with the underlying trend or direction of the data. And we want to try to get rid of that using the standardization process. So there is kind of like a modeling within a modeling exercise that happens. Once all that is done, and now that I remember the order of my animations, we get to the assessment phase. And this is where we're going to either apply a model that has already been built by someone and we've determined that it's usable and appropriate given the data, or we may have to build one from scratch. And then once we fit the model to the data, that's the process of the statistical model trying to match those predictions to the observations. The model will produce estimates, and that's how we're going to be able to determine how the population is doing. And finally, we get to the, oops, forgot my animations again, sorry. Once we build the stock assessment model, we're not quite done. There are a lot of other alternate versions of the model that we're going to need to run. We often call these sensitivities. This is where we try to test all of the assumptions of the model. We really just try to beat the hell out of these things to make sure that they're giving us a consistent answer. And there are a number of other analyses we can do to try and quantify the amount of uncertainty associated with both the data and the model. And so there's a lot of work that goes into this beyond just looking at the data and then fitting the model to the data. In a way, fitting the model to the data the first time is kind of the easiest step. This is the hard part, where we really try to make sure that it does what we want it to do, that what it's intended to do, and is really something that we can stand behind. And that's where we take it to peer review, where experts either in stock assessment or the biology of the animal will review our model and see if we have done our diligence. And if for whatever reason the model does not pass muster, they may ask for a whole bunch of additional analyses for us to do. So we may not even really be done with the stock assessment until the end of the peer review process. And sometimes the model will not pass peer review. It is not something I hope happens during my tenure here, and I aim to avoid it. But I do have some experience witnessing it both at the state and the federal level. And so, as I mentioned before, um, there really hasn't been an opportunity for the public to weigh in on the stock assessment or the data being used uh, until that peer review process. But if you've ever participated in a federal stock assessment or just listened in to a Southeast data and assessment review or CDAR workshop, you have the ability to make comments and weigh in on what they're doing. And I'd really like to move further in that direction. Um, and so I'll be asking later if that's something that interests you and you want to see DMF move forward with. But I think the data and planning sections are where we could really use members of the fishing community's viewpoints the most, because they provide vital context that someone like me, who often sits at a desk most days, just isn't going to get. Again, I'm going to be one of the first people to admit I don't spend all of my time on the water. My expertise is in how these models work and not in fishing. And so I really need other people to be talking to me and sharing what they know with me so that I can see the whole picture. So this leads me to my first pause for questions. And I have some prompting questions, but these don't have to be the questions you answer, nor do these have to be what we talk about. This is just here, in case you want to weigh in on this for me. And so I want to put these out there. Is this public-facing stock assessment webinar or potentially in person, the direction you would like to see NCDMF take? Would you be interested in listening in or participating? And what else would you like to see from the stock assessment program? And I will go ahead and mute myself and let Dan Zapp, our moderator, take questions. He is our FMP coordinator, and he's the person manning the station. So I will stop.
Yeah, Matt, I don't see any hands yet, but there was a question from Adrian. What is the data model source, i.e. where are the test model numbers derived from?
Yes, so great question. I am going to be talking about which data we're using later on and where those are coming from. I'm also going to be talking about which model we're using and what that is based on. So like the framework as well as the paper. I have links in my talk and a PDF of it to share with folks so that they can follow those links to the sources, like where I am getting these ideas from. So, I'm not just making things up. I'm actually researching how we can solve these problems.
Right, and we have a question from Grace online. Grace, I sent you a request to unmute yourself, so you should be able to unmute yourself now.
Oh, can you hear me now?
Yep,
I can.
Oh, I can't hear you very well. I'm sorry. I have an ear infection, so I'm having a very difficult time with this. You said you had a question from me?
Yeah, you had your hand raised. Did you have a question or a comment?
Oh, I am interested in participating. I had spoken to Matt, I think, in the past about my experience, because I'm on the water crabbing all summer and fall, and I have a lot of data. So I'm interested in participating. Why don't I see the faces? Why don't I see myself in the face here?
That is likely just because you have your camera turned off.
Oh, I don't have a camera on my computer. That's why. I guess that's what it is. But I can see you. I can't see anybody else. I can see Matt and the gentleman at the computer at the big conference table. I don't know what else to say. I'd like to participate. So what do I have to do, or will you contact me at the appropriate time?
Yeah, I think the plan is, once we regroup after tonight, we will talk about what the next steps look like, and we'll probably do another kind of press release and give folks an opportunity to join and participate.
Okay, so you have my contact and you'll reach out to me?
I can do that. Yes, I think I have your number still.
Okay, I'd like that because I don't know how these things work. I had a webinar a while ago and I could see people and they could see me. You can't see me?
No, I don't think anybody who isn't technically a host can put their video on. So that, yeah, I think that's just how WebEx works, unfortunately.
Okay. So I'm not able to turn it on. Forgive
That's
me.
right.
I can't hear anything and I may end up leaving early because I feel like I'm underwater.
I'm I'm sorry to hear about your ear infection.
Yeah. Well, anyway, but okay, if you could reach out to me when the appropriate time is, I can share my information.
Sure, I'd be happy to.
Oh, I'm sorry to take so much of your time. I feel like I'm rambling.
You're
Thank you.
fine, Grace. That's what this is for.
Okay, I'm just so ill right now. I can't deal with this.
Okay.
Okay, so I'm
Take
gonna
care of
just
yourself.
watch if
And Grace, I hate to cut you off, but we have some other questions that we want to get to, and we do hope you feel better and you're able to stay on for the rest of the webinar. Matt, I have Glenn Skinner in the room. He has a question, and then we'll get to the other people online.
Okay. Thanks again, Grace, and I hope you feel better soon.
Am I good? Can you hear me, Matt?
Yeah, I can. Hey, Glenn.
First, I just want to thank y'all for doing this because I think it's going to be great in the future. Help us get a better understanding of how these stock assessments work. And my main question right now, I'm getting a lot of text, as you all are, from people who can't hear this very well. So is this something that will be posted that they can watch at a later date, or y'all will make public somehow?
We were talking about posting it on YouTube.
Okay, because evidently some of them, some can hear and some can't, so it would just be probably good for them to go back and watch it. They're having trouble with it. So.
Yeah, I am recording it, so you should be able to.
All right, thank you.
And if people in the room couldn't hear that conversation, we do plan to post this on YouTube at a later date, so it will be available to watch.
I'm going to go ahead and put that in the chat as well.
Okay, and I'm going to go ahead and unmute Brian Kramer, so you can ask your question.
Yeah, thanks for putting this on. I'm not a commercial fisherman. I'm recreational fisherman. I've got a recreational commercial gear license, just 5 pots. I fish on the White Oak River near Swansboro. Just simple one here. Where in North Carolina on the water are you collecting data from?
Yeah, great question. So we are collecting data in Albemarle Sound, Pamlico Sound, and further to the south. I'm actually going to put up a map of where the data are coming from in a little bit.
Thank you for that question, Brian. And I'm going to unmute Joe so you can ask your question.
Hi, Matt. Appreciate the format here. I'm just curious from the standpoint of the blue crab being traditionally a boom and bust species, going back all the way to the 1930s. The state even put in a sponge crab law back in the 1930s because they thought they were going away. In terms of a stock assessment positioning, how is blue crab unique? Because these things can grow to maturity so quick. A bad winter can change everything. Rain events can change everything. It seems there's so many factors in this, and because they're a high fecundity and they do spread out in the ocean into different states, what is your what makes the approach to this a stock assessment different from your standpoint?
Like in general, or different from like the previous stock assessment for blue crab?
I guess in general, compared to I would think a slow growing species, I kind of understand, but when species have so many eggs and the boom and
Yeah.
bust happen for so many reasons outside of fishing control, it just seems like you could be easily chasing your tail with a stock assessment like blue crab.
Yeah, no, great point. So a couple of ways that this is going to be different is we're going to be using a size-based model, which was created explicitly for crustaceans. And so the way growth is modeled is really well suited for trying to model blue crab population dynamics. Another thing that we're going to be doing, I'm kind of burying the lead here on some stuff later, but that's fine, is we're going to be using season as like our time step instead of year, so that we can measure some of these processes over a shorter time period, since they're such a short-lived animal. The part about the environment, we can deal with that and look into that in a couple of different ways. One is how we try to do that standardization of our survey data. We're using a method that does a really good job of kind of getting rid of noise that's happening over space and time. And this has been proven to be a really good way to try and implicitly model the effect of the environment. So that's one way. The other is we've been looking into some data sets that are related to like climate and weather processes that would affect a lot of the environmental features that we know affect blue crabs' life cycle. So salinity, temperature, wind, and we're trying to determine if we can make any kind of, if we can find a relationship between that and what is happening in the blue crab population. So I guess to summarize, it's different in the sense that it's not like a fin fish at all. We're trying to use something designed specifically for crustaceans to try and get at what is going on. And we are actively investigating a lot of different potential drivers of what's happening with blue crab, including working with folks from Janet Nye's lab at University of North Carolina. Her folks are, for example, looking into predation. Like, is there a relationship between the number of species we know eat blue crab and like a decline in the number of blue crab? So we're really throwing our whole weight into this one, I guess I would say, to wrap things up.
And thank you for the question, Joy. I have you muted again, but if you have any other additional questions, you can just raise your hand again and we can follow up later. There were a couple, Matt, there are a couple agreements in the chat about wanting to participate in the stock assessment process and wanting to be involved in the process and wanting to set up something more like the CDAR process. I'm sure you've seen some of those. There are some other questions in the chat. We had one from Lauren Birch. Are you starting to sample in the Currituck Sound? We have about 15 people watching here and would like to be part of sampling if needed.
Yeah, thanks for that, Lauren. And I heard about your watch party, which I think is awesome. So we are definitely having conversations about future sampling effort, expanding our coverage over North Carolina waters and working with members of the fishing community to collect that data. I'm sure it's no secret to anyone that, there are budget issues and staff limitations. Like I said, we're an army of two in the stock assessment program. So we're definitely interested in working with the community on getting more data. I don't know off the top of my head if we're sampling in Currituck Sound, which might mean we're not. Dan, do you know off the top of your head?
We do have some sampling in Currituck Sound, yeah.
Okay, thank you.
And there's also a question from Sarah H in the chat. What is the timeline for the stock assessment process generally? Like the time of publishing, and how often are these stock assessments conducted?
Man, that is a great question. It depends, which is the least satisfying answer I can possibly give. I would say for for this stock assessment, we've been aiming the whole time for somewhere about a year from start to finish. It really depends on whether or not there is a model you can already out there you can make work for you, or if you have to actually build one from the ground up to fit for the stock that you're interested in. If that's the case, it can take a while. So I would say on average, somewhere around 9 months to a year is what the timeline looks like. And as far as how often these are conducted, that also kind of depends. I think in the ideal world, you would try to either update or do a new stock assessment at least every 4 to 5 years, because the less often you have updated estimates, the higher your risk that the projections forward in time kind of mismatch with reality. But there are alternatives and sort of like intermediate analyses you can do between stock assessments to try and keep your finger on the pulse of how the stock is doing. And that's definitely something we're talking about a lot in the stock assessment program. I think I answered your questions. I don't know how satisfyingly I did it, but yeah.
Okay, I don't see any additional hands, and Sarah H says thank you in the chat. I see we have a couple more minutes in this block of questions, and I see Ken Siegler has his hand raised. So Ken, I'm gonna unmute you, and you should be able to ask your question.
Okay, what I'm concerned about is carrying capacity of the nursery areas and the backwaters with stormwater runoff from development and whatnot. We know that's been affected. How are you comparing today's data to previous data 30 years ago, and in estimation of what the stock should look like at the current time?
Man, tough question. Yeah, we know that coastal development and runoff is causing a huge problem for habitat, and we know that these seagrass habitats are really critical to blue crab settlement and growth and survival. And we don't really have a great handle on how much of that habitat is out there relative to what there used to be. And so unfortunately, we're kind of forced to look at the time period of data we have and try to figure out when things were doing well versus when things were doing less than well. And so we are we are going further back in time than the last stock assessment. We're going back to 1982 instead of the mid 90s, where we saw that huge concentration of blue crab and record catches. So I think the model will get a better sense, at least, of the fluctuations in the population over the course of those 4 decades than the last stock assessment was able to do. But we're not really able to go any further back in time because the data just stopped being as reliable at that point. Like, they're really noisy, they're really uncertain, and they have caused problems with some of the early models that I've tried to fit them to. But I share your concern.
And so, Matt, we're at about 15 minutes for this block of questions. I don't see any other hands or anything else in the chat. If people have questions as we move through, feel free to add things to the chat or raise your hand when we get to the next stop. And other than that, I think we can continue.
Okay, thank you, Dan, and thank you everybody who raised their hand or put a question in the chat. I really appreciate it. Oops, forgot that part. Yeah, I think you're all keenly aware of this by now, so I'm going to stop hammering that point. All right, so I've got another set of terms I'm going to introduce that are going to be important for the rest of the content tonight. So the first is what a benchmark stock assessment is. So there have historically at NCDMF been two types of stock assessment. We're going to be looking into more analyses we can do than just these two, but I want you to be familiar with these two before we talk about the peer review from 2023. So the benchmark stock assessment is a comprehensive review of all the data out there and usually involves fitting a new stock assessment model to those data. And it's either pre-built by someone else or it's made from scratch. But then there's also update stock assessments. And so this tends to involve using that same benchmark stock assessment, but all you do is add more years of data. You don't make any changes to how the model works other than adding in those new years. And then I've mentioned this before and kind of defined it a little, the sensitivity analysis. So this refers to different configurations of the stock assessment model, specifically to figure out how sensitive it is to those settings. So like if we were to assume a certain level of natural mortality, so the rate at which crab are dying from natural causes, that might change the output of the stock assessment model. And we want to be aware of how and why it might change the output. The other main reason we pursue sensitivity analyses are to explore other data sources, to determine if there are additional data that we may not have prioritized, whether we can use them and whether they tell us anything informative. There are often the case where we add a new data set and if there's not enough information, the model may just ignore it and give you the same result. But that is useful information for us to know and to be able to communicate to you. Fishing mortality. So I'm going to be talking about this a lot. This is the rate at which, in our case, crabs are dying from being caught and being caught in the fishery. Spawning stock biomass. So this, we're only going to use this maybe one time, but this refers to the amount of crabs that are contributing new individuals to the population. This is usually the number of females, and it can be measured in weight. Sometimes it's measured in the number of eggs, but that's usually for fish when you have information on how fecund or reproductive the animal is. And then the last two, overfishing. This means the level of fishing mortality has exceeded some threshold level. I refer to that very generally because that's always going to be pretty case specific, that threshold level. And then overfished, that means that the amount of spawners has dropped below some threshold level. Again, this is something that you investigate on a species specific level and try to come up with based on, your best understanding of what the lowest level of the population can be and still be reproductive. Okay, so let's talk about the 2023 update assessment peer review. What happened? So in 2018, NCDMF conducted a benchmark stock assessment. So this was moving from the old traffic light analysis that was done for blue crab to a new model. And the estimates of that model of population size and spawning stock biomass suggested that the stock was overfished and overfishing was occurring in the last year of the model. Last year of the model was 2016, even though the stock assessment was conducted in 2018. So important caveat here, we are always chasing the past in stock assessment. It takes a long time to process data and to go through it and make sure that it's error-free before it makes it to a stock assessment. And so a lot of the time we're usually at least 1 to 2 years behind, and we have to kind of rely on how we think the population was doing in the past to make decisions about the future. This is another thing that is unfortunately unavoidable in this field. And so then in 2023, NCDMF conducted an update stock assessment. So the model did not change, only new data were added. And then the estimates of population size and fishing suggested that overfishing was occurring and the stock was overfished the entire time, which is a red flag. So the peer reviewers did not recommend using this model for management, and NCDMF agreed and did not use it for management. The peer reviewers had two major concerns, one having to do with data and one having to do with the model. There were problems with fitting this this updated model to our survey data in particular. The problem was that it was producing some patterns in the way it was fit that also were raising red flags. I'll get more into why in a second. The second issue is that when you see this unrealistically high level of fishing mortality where the stock is just never doing well, this often indicates something called model misspecification. So some setting within the model is not right. It's not able to accurately model the population dynamics of the stock. And so, as I said, NCDMF did not recommend using these results from the update for management. So let's dig into what these data limitation issues that we ran into, because fundamentally, a stock assessment can fall apart when you have either problems with your data or a problem with your model. And in this case, unfortunately, it was both. And so when it comes to the data limitations, first, I want to mention that most of our scientific surveys are operating in different parts of the state at different times of the year. There's no survey that is going out there and doing like a comprehensive survey of all waters. And so as a result, a lot of these survey programs are producing trends in the data that could be going in different directions. And so when you have this issue, if data from different surveys have different trends, this is called data disagreement in stock assessment modeling, and it can cause problems with estimation. So basically, if you have a bunch of different signals that the model is trying to track, the model can get confused and try to follow one signal and another, and end up not really knowing which way to go. And so, for example, if one survey says that blue crabs are increasing in one area and another survey says that they're decreasing in another area, this can result in that data conflict that I'm talking about. And I think that this is basically what was going on. Another aspect that I won't go too deep into, because we're going to talk about how we kind of solved it in a second here, is that when we do this standardization process of these data, we are really trying to get rid of all of the noise that could come from a bunch of potential sources. It could be coming from where you're sampling. It could be coming from an effect of the environment. And the fits of that update model to these data were suggesting that there was noise that was not being accounted for. And so that we really needed to pursue a different kind of standardization model for our data before we fit the stock assessment model to those survey data. And so the peer reviewer recommendations from this were to look into combining our survey data across the different programs. So basically, try to expand that spatial coverage as far as we can go and reduce that potential for conflict among data sources being used in the model. So the next is the model limitations. So the this really meant to be 2018. I got the date wrong. Don't hold it against me. The 2018 benchmark assessment and the 2023 update used what was called a two-stage model. So this models blue crab populations as having two stages in their life. Basically, the crabs that are too small to enter the fishery and the crabs that are large enough to enter the fishery. And so I want to point out that this is not an uncommon model specifically for blue crab. we actually have seen these used both in the past and currently in a lot of areas on the East Coast and in the Gulf. So the Delaware Bay and New Jersey Bay combined blue crab stock assessment uses a two-stage model. Chesapeake Bay used a two-stage model until their most recent model. Florida used to use a two-stage model, and Louisiana still uses a two-stage model. So it is a fairly common stock assessment model specifically for blue crab. That being said, an individual blue crab is not alive for a long time, and I make this silly joke here about not being here for a long time, but maybe a good time. And so trying to model everything that happens in a blue crab's life over those two very, very coarse stages and within a single year, it is a huge simplification. I think everybody can at least agree on that. So the peer reviewer recommendation was to consider a seasonal model. So don't look at it from year to year, look at it on a seasonal basis if possible, and then move to a size-based stock assessment model so you can better capture those important vital rates like growth and survival, which are happening quite rapidly early in a blue crab's life. And so that basically gave us a roadmap to what we should do with this benchmark stock assessment. And so what we've done is we've combined data from multiple surveys using what's called a spatiotemporal or space-time model. I've got a link here to a paper that describes it in gory detail. And this allows us to do that, reduce that potential for data disagreement in the stock assessment model, while giving us a trend that is more representative of North Carolina as a whole rather than just where we were sampling with that particular survey program. We're also using a seasonal size-based stock assessment model to model the North Carolina blue crab population dynamics. The only other area that is currently doing this right now is Chesapeake Bay. They just finished their peer review for the new blue crab stock assessment, and they are using, in fact, a very similar size-based stock assessment to the one that we have chosen and I'm going to describe. And then we also considered going further back in time, for the reason that we were talking about earlier, is that the last stock assessment started really right at the fever pitch of an anomalously large amount of catch and probably the highest, the largest the population ever was over time, at least over the last 50 some odd years. And so that'll allow us to give the model a better sense of scale. And then finally, we really wanted to investigate potential environmental effects, since we know there are so many features of the environment that could potentially be playing a role in what is happening out in the water. So here I'm going to pause again for questions. I think we're doing really well for time. Do you have additional questions or concerns about the 2023 update stock assessment peer review? And I'm also happy to, answer other questions and address other comments here.
We can give it a couple seconds. I don't see any hands right now. Okay, we have Glenn Skinner has a question.
Yeah,
Go ahead, Glenn.
One of the things you and I've talked about, and you did a real good job of explaining it here, the problems with the stock assessment, and we've had a lot of stock assessments in this state where peer reviewers have pointed out either no trend in data or the data didn't align well. Each survey showed a different trend. And we've also had a lot of stock assessments that have been used that show overfishing for 20, 30 plus years. So I guess what I'm asking is, are all peer reviewers not created equal, or some more willing to accept uncertainty than others? Because it seems like there's really no standard here for whether a peer reviewer accepts it. It's based more on personal or professional opinion. And this stock assessment is going to be peer reviewed we would like to have some confidence that peer reviewers were going to look for those falls and not just note them in a peer review, but also say, hey, it's not usable. And I'm not going to mention any species. I don't want to get into a conversation outside of blue crab, but we have had a lot of stock assessments that have showed overfishing the entire time series, which quite frankly was impossible to still have the level of fish we had, and then also pointed out the same problems with survey data. So I'm just wondering how some of those get approved for use and then some don't, kind of like the benchmark blue crab did, and then the update did. It's a little confusing to me.
Yeah, I mean, you are not wrong about your statement about it being kind of up to peer reviewers at an individual level. If I had my druthers, what I would do is try to get the people who are either most familiar with the kind of model I'm using and or the people who are most familiar with the stock that I'm trying to model. Because I think between those two, that's your best shot at making sure that you catch any of those potential problems, whether it's with the model itself or with how like assumptions you're making about the biology of the animal. And so I can't, having only been here for 11 months, I can't really speak to past peer reviews very well. I will say that I think that the peer reviewers did a really good and dutiful job with the 2023 update assessment. And I appreciate their work because, I mean, they basically did a lot of work for me, telling me what direction to go. Some of the others, and this is another challenge with the peer review is people you can actually manage to get to do it. You got to get people to take time out of their schedule to come and devote a not insignificant amount of mental effort into being diligent reviewers of a lot of work. And so sometimes you might end up with somebody who might not be your first choice, and they may be more forgiving of uncertainty, as you said. I can only speak to what I plan to do, which is I'm going to reach out to people who have done blue crab stock assessment, including the analyst who just did the Chesapeake Bay blue crab assessment using a size structured model. I also want to get the guy who basically pioneered size structured models for crustaceans if I can. And then potentially somebody who has done a lot of blue crab ecology and biology research. That would be my dream team.
Okay, I have Doug Rader. I'm going to unmute you now.
Thanks, Matt. Really great so far. I look forward to hearing the rest. Just as an observation, I think the recommendations coming from the UNC Collaboratory back to the people of the state of North Carolina are really valuable in this regard too. And I hope the audience realizes that one of those recommendations, including the development and the maintenance of a CDAR-like capacity in North Carolina. So I think that's really an important opportunity. Independency of it, but not having that yet, though, it seems like the other thing that Chesapeake Bay wrestled with was the predational effect that you mentioned earlier, and including the necessity of or perhaps advantages of multi-species models in terms of looking at key predational populations. And of course, obviously, we're not in the position to be able to do that. But I just wondered if in the development of that Chesapeake Bay size structured model that you talked about, whether there was anything interesting that we might be able to either use or use for sensitivity analysis looking at predational effects.
Yeah, it's a great question, Doug, and I appreciate your comment on supporting the more CDAR-like process. I know that they looked really closely at blue catfish predation, but they didn't find that it was consuming crab at a level that would have a huge effect in the stock assessment. Yeah, tough question. I mean, the work that Janet Nye's lab is doing is probably going to inform any potential sensitivity analyses we do to try and determine if we can model a predation effect. I'd have to dig deeper into the report on the Chesapeake Bay stock assessment to determine if there were sensitivity approaches that we could adopt ourselves. I'll have to dig into that, but thanks for raising that issue.
Great, that's great, Matt. And just as a quick follow-up to the person that made the comment about primary nursery area and recruitment effects, ecological effects on stock health, I just make sure that people that are listening realize that our secret weapon there, admittedly not yet full-fledged, is the 3-commission coastal habitat protection plan. And if you're not aware of that, that mechanism is up for revision and reauthorization this year. So by November of 2026, that plan will have been out for public comment. And I just recommend to each and every one of you that you take the time to think about this through both approaches and take advantage of those public input opportunities as well. Thanks, Matt.
Thanks, Doug.
Okay, I don't see any other hands raised and I don't see anything in the chat. So Matt, it's up to you if you want to move on. Looks like we're good to go.
Okay, yeah, let's keep going. So the next section of this has everything to do with the data that we have been looking at. I want to mention that we have chased a lot of threads for the stock assessment, and so I can speak a little bit to what didn't make it here today, but there is a subset that we're going to focus on, which are the data that we're prioritizing and have prioritized for fitting the model to. So from fisheries, we have commercial hard crab harvest during 1982 to 2024. And we also have size composition data from our fish house sampling corresponding to that commercial hard crab harvest during 1995 to 2024. I'll note that the reason that these time periods are different is because that fish house sampling program did not start until 1995. Otherwise, we would be looking further back in time. I realize there are other fisheries data. One of the ones that we're looking into including in a sensitivity are recreational removals, though I will say that those come from MRIP, and I do not think we have a terribly great handle on the magnitude of recreational landings because of that. From our NCDMF surveys, so we combined our catch rates, so the number of crab per minute of sampling from our juvenile anadromous trawl survey, which is program 100, the North Carolina Estuarine Trawl Survey, which is program 120, and our Pamlico Sound Trawl Survey, which is program 195. And many of you have probably heard that program technically ended at the end of 2024. And we are currently looking into ways that we can replace that sampling in that region. We also have size composition information from each of these programs. And I'm going to talk about what each of these sources of data does in terms of informing the model and why we would want these data. And then finally, I'm going to talk about the main environmental data set that we've been looking at, which is the North Atlantic Oscillation Index, also during 1982 to 2024. So here I have what we call a time series. It's just the data plotted out over time of annual commercial hard crab catch from 1982 to 2024. And as I mentioned before, we really see this huge peak in the mid 90s to the late 90s. followed by, kind of a drop off around 2000. It stays a little bit level up until around 2010-ish, and then it kind of starts to go down. And I do want to acknowledge, I have heard from a lot of folks that one of the reasons that these have declined is because folks have been exiting the fishery. So I'm not here to make any kind of inference yet about why we're seeing what we're seeing. That is what the stock assessment is for. And then over here, since I measure this in thousands of metric tons, I've got a conversion here just for reference. 1,000 metric tons for reference is about 2.21 million pounds, and 15,000 metric tons is about 33.1 million pounds. And so that should give a pretty good idea of how large some of these landings were over time. And it never really goes below about 5,000 metric tons, so about 1 million pounds. So if we break this up by season, first of all, let me talk about what season even means here. So we looked at all of our data together and we tried to make a determination about how we could split this up season. The decision we came to was to split it up by January through June and July through December. And the reason was because we had a roughly equal amount of data over those two time periods. Obviously, most of the fishing season is going on in the late spring through the fall, and so that's not contained within one season. But we also are able to get at things like the number of new crabs settling in the seagrass if we split it this way, because the fall months are when we see peak recruitment being blown in from or peak larvae being blown in from the ocean. And then in the spring, the early winter and spring months, we start to see more of those small crab growing in the eelgrass. So I broke this down by season just to give you a sense of how these look when we split them by these 6-month periods. Overall, they're pretty similar. But I will note that the scale is different. As I mentioned before, we're probably capturing way more of the fishing season over here in what we're calling season 2. And so this ranges from, around 3 to 20 some odd thousand metric tons. So that's really the bulk of when the harvest is occurring. But there is still some harvest during season 1, like during April and May, which has a much smaller range from about 2 to 8,000 metric tons. But the main point I want you to take away is that the patterns are pretty similar. And so here I have the size composition from the fish house sampling. I know this is a lot, so the way I want to break it down is we're looking at what these size classes on average from the fish house sampling look like. And so each of these lines from top to bottom represent the largest to the smallest crab that show up in the fish house samples. So basically, we never see anything under around the legal size here. And we see that from 1995 to 2024, it's really consistent. And so what this is telling us is just that a very consistent class of hard crabs are being brought to market from the commercial fishery over time. This is still useful for the model because the model needs information on how capable this fishing fleet is of catching a crab within a given size. And something I forgot to mention on the landing slide, why we care about getting these catch data is because these are ultimately what give the stock assessment model a sense of scale. They're better able to determine how many crabs were there if they know how many had to be there to support this fishery. Okay, sorry about jumping around. I just got a little ahead of myself. So here, this is in millimeters, but I have a conversion here for reference. So 150 millimeters is about 5.9 inches. And so this distribution is very close to hovering around the legal size limit, which I believe is 5 inches. All right, here is the time series of the combined survey data. So first of all, 100 again is that juvenile anadromous trawl in Albemarle Sound. 120 is the estuarine trawl, and 195 is the Pamlico Sound trawl survey. And so this is the output from that space-time standardization model, where we really try to filter out as much noise that could be due to a number of different factors as possible. And so in the black here is an estimate of relative abundance. And so in that sense, this y-axis, this index, these units are meaningless. This is basically just meant to measure what the overall trend of the population has looked like over time. This is also technically on a seasonal level. And so the year is here, but you can see in between each of these, there's another point, and that's the season. So you have 1982 season 1, 1982 season 2, all the way through 2024 season 2. And so what we see here by combining all of these data is we really see that boom and bust, especially from 1982 to around the early 2000s. We see a little bit of a decline, but not radically so here. And then it jumps up during 2010, goes back down a bit, jumps up around 2018, 2019, goes back down a bit, and starts to jump back up a bit around the end of this time period. The gray around here are the confidence intervals. So this represents the upper bound and the lower bound of the estimates. So in most of these years, it's pretty tight. So the model seems to have a pretty good handle on the range of relative abundance in each of these years. So the reason that this is particularly important to stock assessment, you may have already gleaned this from what Glenn was talking about, is this is the signal that the model is going to track for the direction of the population over time. And so it's important to get a measure that is consistent and concentrated like this and not going to cause that data conflict. So to kind of reiterate, landings give the model scale, size composition tell about not just the probability of capture, but it can also give us information on the effect of fishing. If we saw a really clear effect of high fishing pressure, we might expect to see the size of crab on average go down. That's a really common effect we see in fisheries, both for crustaceans and for finfish. Same thing with like an age structure in a finfish population. And then finally, we have this index of relative abundance, which the model needs in order to know which way the population is trending. But overall, this is fairly noisy with some slight declines happening here and there, but with notable increases over the last 15 years. So if we break this down by season, like we did with the landings data, we can see that the trends are actually a bit different here. So during January through June, we've seen a really consistent decline. Not quite the case in season 2. In season 2, it's a lot more random and noisy, with even some much higher peaks occurring later in this time series. And so ultimately what I see here is a noisy but steady decline in season 1, but maybe a slight decline in season 2. One thing that catches my eye is the lows keep getting lower here in this sort of boom bust cycle, but we do see these really high highs later on. So interesting, but we can't really make any conclusions just yet. I also want to note that the index scale is different here. So the scale of relative abundance is generally higher in the beginning of the season 1 time series, but it's a little bit more truncated in season 2. This is probably because a lot of the sampling programs are sampling in areas that have already been fished. I would not be surprised if that was the reason that relative abundance on the whole. Sorry, I saw the chat and I have bad ADHD and get distracted. Yeah, I agree. That would be interesting to look at. Thanks, Brian. Okay, so now I want to show you how the distribution of abundance has looked over not just time, but also space. And so this slide is sort of meant to burn into your retinas the spatial scale of our sampling. So here we have mostly Pamlico and Albemarle Sound. And each of these represent one of the programs. So program 100 up here in Albemarle Sound are these little orange triangles. Program 195 are these blue circles here. And then program 120 are these hot pink crosses. So I'm sure the first question that's coming to your mind is, where's the rest of the sampling in the South? And that's a great question. So the only program that samples blue crab further to the south is program 120, and it mostly catches smaller crabs. And so for the purpose of combining the data in this standardization model, we looked at it both with those data to the south and without. And when we included those data to the south, it didn't change anything. And the estimates of abundance in those areas relative to the rest of North Carolina were quite low. And so one of the things that we often seek when we're modeling is called parsimony. We try to give the model, we try to get basically the best model with the least number of parameters to estimate. And so excluding that area when it didn't change the results, we thought was an appropriate choice here. And so here is the spatial, what we call mesh, that we're trying to estimate our abundance over. And you can see it's not an equal amount of sampling. Pamlico Sound is much more heavily sampled than Albemarle Sound, but we thought it was really important to try and make sure we were capturing abundance not just in Pamlico Sound, but also in Albemarle Sound for this analysis. So the next slide is going to be a bit of a bear, so bear with me. I didn't plan that joke, I swear. So I hope everybody remembered that figure that I just showed. So here we have the first half of these abundance estimates over space and time. So first of all, we originally tried to take data all the way back to 1974, but as I've alluded to, the data are really uncertain going back that far. And with our survey programs, it's only program 120, that estuarine trawl survey, that goes that far back. And during those first several years, there were a lot of sampling changes as staff in those days were trying to figure the survey out. And so it wasn't really consistent sampling. And for that reason, we basically left it out. We didn't consider these. And so I've included this black bar so that way we don't focus on that. Where I want to start you is where, we're really starting the model, which is 1982. And you can see up here, if everybody looks in the top right, that there are a lot of hot spots. The high abundance is in these greens and yellows. Yellow, the hottest color, being the highest abundance, and deep blue being the lowest. And so you have a lot of hot spots in Albemarle Sound to the top, going down into Pamlico Sound. It fluctuates like we saw in that time series. You have years where it's really high, and you have years where it's not so high. That's not too surprising. As we get further toward the 90s, you can see that there are really big hotspots, especially in this area here in Pamlico Sound. And as we get into the early 90s, we persistently see some of these hotspots around those same areas, but also farther north. In 1996, 97, 99, we've got hotspots all over the place. Crab are really abundant according to our estimates coming from these sampling programs. So let's look at the back half, because this is where things really start to change. When we hit 2000, we still see some hotspots in similar areas. In like 2001 and 2002, still pretty high. Even 2003 has got some fairly high hotspots. But then as we get to the mid-2000s, we don't see quite as many. Very cool colors in general. Corresponding to that increase around 2010, we do start to see those hotspots come back. but this is where it gets really interesting to me. The hotspots start to be more concentrated up in Albemarle Sound compared to Pamlico Sound. And we see these periods in the mid 2010s where we don't quite see as much. And when it lights up again in 2018, the majority of the abundance is really coming from Albemarle Sound. We do see some hotspots in 2019 here, but as we get to the end, those hotspots are really concentrated in Albemarle Sound. So we've seen a noted decrease over space in that Pamlico Sound, that much larger Pamlico Sound region, and a pretty steady amount of abundance in Albemarle Sound. I'm actually gonna leave this up for a second so folks can take some time to digest, because I realized I went through that fairly fast. And it's quite an eye exam, I imagine, if you're looking at it on a computer. I have it up on my big monitor, so it looks great to me, but I know it's probably not to you. I do not have the salinity numbers, but that would, I think we do have the salinity, but we have not plotted the salinity the way we have plotted this. So that would definitely be interesting to look at.
Hey, Matt, do you mind if Glenn asks a question while you have this figure up?
Sure.
Sorry not to wait for the pause, but I thought it'd be helpful while this up. The one thing I noticed is we could start to see a change when we started having the landfall and hurricanes in the late 90s. And of course, we've had them right on. And most of the time, those storms seem to impact the Pamlico Sound region of the state and south more than they do the northern part. And I'm just wondering, I know Janet and I does work with some of the environmental stuff, you know, the AMO or whatever. Has anybody looked at that to see if maybe that there's a correlation there? And as we come out of that hurricane cycle, as we always do, which lasts generally around 30 years, would we expect to see this population in the Pamlico Sound area start to expand again?
That's a great question. As far as I know, there haven't been any other stock assessments that have specifically tried to dig into those big climate patterns. That's one of the reasons we're trying to look at NAO, is because that also corresponds to those years of really warm, wet weather, high rainfall, and increased storms in the region. So in that sense, I'm not too proud to brag that, you know, I think we are the first team that's really trying to dig into that. All right, I am going to move forward, but we can continue to talk about it when we get to the question section. So let's take a look at the size composition information by each of these surveys. So the first one here is from Program 100, the survey operating in Albemarle Sound. Same kind of setup as we saw with the fish house sampling. So each of these lines from top to bottom correspond to the largest to smallest crab that are showing up. And so first of all, it has a really large range from really small crab to relatively large crab. And most notably, what I see is it's pretty stable. This looks like a pretty random pattern to me, with the exception of these bumps around 2010 and around 2018-19, and then again toward the end. So what this tells me is that these size composition data may be picking up on some of those bigger cohorts that are entering the population, which is essentially the kind of information that we are looking for and make this kind of data informative. When we look at the size composition from Program 120 from the Pamlico in the south, and I want to note that the southern data were not excluded here. They were only excluded in the index, but they are included within this. We see that this is a smaller range of sizes, or I'm sorry, smaller crabs in general are being sampled in this survey. And this here, for the most part, is pretty flat up until the early 2010s, but then we start to see a bit of a decrease in the largest crab, the second largest, and the median size here. And then finally, the size composition from program 195, just from the Pamlico Sound, we see pretty regular, sorry, it's getting late, pretty regular periods of highs and lows from 1982 to 2000. It's picking up on those big spikes corresponding to lots of crabs being concentrated from hurricanes in those years, followed by a decline from 2000 to 2010, a spike in 2010, again, probably picking up on a cohort, and then another spike in 2018, 2019, but then a decline in the end. And so the size data and the estimates from our index of relative abundance over space and time are, I think, quite consistent, which you want to see. You want to at least have agreement between data that are coming from the same source. And then finally, I have plotted here the North Atlantic Oscillation Index. So the North Atlantic Oscillation is a large-scale climate pattern. It has cycles or phases that it moves between from year to year. And so when it's above zero, it's considered to be in a positive phase. And when it's below zero, it's considered to be in a negative phase. What that means in terms of weather and environmental effects in North Carolina is those positive phase years are when you have warmer, wetter weather, a lot more rainfall, a lot more storms. And then the opposite is true in those negative phase years. You have colder weather, you have drier weather, you have less wind and fewer storms. And so there are probably a lot of connections being made here because this is a major driver of a lot of the things that would affect a crab, especially transport when they're in that larval stage in the ocean to the estuary where they need to, actually grow. And so that is the reason we have prioritized this as far as the environmental data set we're looking at. We dug into other environmental data sets like water quality, and the longest water quality time series was coming from Cape Fear, but that's mostly going to tell us about what's happening in Cape Fear, whereas something like the NAO is going to tell us about what's happening at a state level and larger. And so what we're really trying to do is figure out if we can find a stable relationship between the blue crab population dynamics and a process like this, so we can try to determine the degree to which the environment is playing a role in the way the population changes. Okay, so to summarize what we just went through, what do these data and analyses tell us? So landings have declined, probably for a number of reasons. Sizes brought to fish houses have been consistent for 30 years. Abundance at the population has declined overall, but not uniformly over space. The decline appears mostly to be in the Pamlico Sound, and recently, while Albemarle Sound, abundance seems relatively high or stable. And similarly, the size of larger blue crabs has decreased recently in the Pamlico Sound while remaining quite stable in Albemarle Sound. And so, importantly, I want to make the point that these data and these analysis do not a stock assessment make. If it were this easy to figure out how the population is doing just by looking at these data and doing these sort of preliminary analyses, that we'd be done. But the truth is, the stock assessment has the feature we're interested in, which is integrating all of these data and estimating things we couldn't possibly see so that we can get a fuller picture of how the population is doing. And so I want to emphasize, I don't have any conclusions yet. I'm just telling you what I am seeing in the analyses and the data that I've plotted. And so with that, I want to ask if anybody has any questions about how we did these analyses, and I do see that there's a question in the chat. So I'll start with the question in the chat. The size compilation slide definitely depicts decreases in sizes following the hurricanes in the late 90s, Irene in 2011, and Florence in 2018. This is striking in that slide. Well, thank you. Yeah, I agree. It's really interesting to be able to plot the changes in size over time. That's why I find that particular visual to be useful. I'll go ahead and pause because I think someone's hand went up.
Yep, I have Christina Bridges with her hand up, so I'm going to unmute you now. Christina, you should have.
Yes, sir.
Okay,
Can
go
you
ahead.
hear me?
Yep, we got you.
Yes, loud and clear.
My question is, when they do the fish house studies and the sampling and tagging, have they informed you that most fish houses will not allow them to measure their number ones? And the number ones are usually your higher size crabs. And have you added that into your stats or numbers?
That is the first time I'm hearing that. So I will have to connect with our folks who are doing the fish house sampling to dig into that and determine if there's anything that we can do to account for that in the analyses. But thank you for letting me know. That is new information for me.
And there's a question in the chat from Lauren Birch. What would cause such a discrepancy in the fish house sampling size and the program sampling size?
So I think it has to do first with the fact that, you know, you're bringing crab to the fish houses for a different purpose. You're trying to catch particular sizes of crab that are going to be marketable, whereas the surveys are really just trying to catch whatever is out there. I think it's just a difference of purpose. You know, people go commercial fishing is happening to provide seafood, whereas we're doing the scientific sampling to get as broad a sample of the size structure of the population as we can.
Okay, and then I'm going to unmute Joe.
Matt, this is really fascinating stuff. Incorporating this weather data, something I've wanted to see for the longest time, and I'm wondering. I mean, if you had water quality monitoring stations and you continue to, you know, perfect or add weather salinity data into these sets, and I know it's a lot of information to combine, but that could get to the point where you can almost be predictive. And I'm not saying it's right all the time, but you might be able to say, hey, I'm looking at a year class color, I'm looking at the trend going up because of this. Instead, because all of these, I tell you what has always frustrated me about these stock assessments and any of these conversations is it always goes back to fishing, and we never, and outside of us being irritated as fishermen, it's not telling me anything. Like I'm a crabber. I want to know. So when I see long-term data and weather overlaid against, and if we had water quality monitoring stations on boats or even in certain areas, man, we could really learn a lot more than just overfished or overfishing. So, I mean, this is all new stuff to me, but I'm just curious, is that something, the more data you get for a base level species, could you imagine a time where a stock assessment could be predictive of the next year?
You know, the challenge that I have run into when it comes to trying to link the population dynamics with an environmental variable like salinity is it's tough to find a stable relationship, like something that is so one-to-one that you can actually get that predictive ability. That doesn't mean that you couldn't use that information in another modeling exercise that could be considered together with the stock assessment when trying to make management decisions. I think that stock assessments, as you've said, are very good at getting at overfishing. Where they fall short is integrating elements of the environment. You try to get at that implicitly through things like the standardization exercise of your survey data, um, which is often the best you can do with a stock assessment. The stock assessment that I chose has the ability to build a time series of environmental variables in it, in as much as it might be able to explain recruitment. I think there was some work out of Jay Chow's lab at NC State that was looking at like habitat suitability monitoring. And I know that there's been some work on like snapper grouper stocks where they basically look at the environmental conditions that have been changing over time in a similar model to the one that I presented here, and try to predict where good habitat is going to be, which I think is probably the closest thing we would be able to accomplish.
Okay, I think we have a question in the room, and then we'll go back to the people with their hands raised.
Matt, I had the privilege of doing both the juvenile survey when I worked here at the division and the Pamlico Sound survey. And I know a lot of people raise questions about their effectiveness at catching crabs because they're not designed specifically to target crabs. I can tell you I've measured a heck of a lot of crabs out of those surveys, so they do catch crabs. But one of the things, the limitation seems to me, they catch more juveniles than anything else. And last summer, Richard Newman sent me a paper that discussed the possibility of using the division's independent gillnet survey for monitoring the adult abundance, because those gillnets catch quite a few adult crabs, and also monitoring the movement of these females as they move from the upper estuaries towards the inlets to spawn. And I'm wondering if y'all have looked at that to see if that would help with adult abundance and fill that gap. I've had concerns for years about using these trawl surveys, not for crabs in general, but mainly for the adult abundance part.
Yeah, that's a good point. We did look at program 915, the gillnet survey. The problem with that data is it was just flat. There were no peaks and valleys in both the catch rates and the size composition. And the range of sizes caught wasn't very different compared to like the program 195 range of sizes. And so we ended up deciding not to use those data because we figured it just wasn't going to be informative.
Do a real quick follow-up. I'm just wondering if where that was flat, have you looked at your observer data for the anchored gillnet fishery? When I took observers, they recorded everything I caught, and I would just be interested to see if that observer data showed a flat trend with adult crabs being caught, or showed some other trend, just as a comparison to see. It just seems strange to me to have real flat data over a long period of time. So.
Yeah. No, I have not looked into the gillnet observer data. Do you happen to know the point of contact so I can reach out to them?
We'll get you in touch with them, Matt.
Okay.
Yeah.
Thanks.
And we're gonna go to Christina Bridges again. I'm gonna unmute you now.
My question is when you did the trawl samples, what was the ability of the person dragging the trawl net? I mean, have you thought about working with the commercial fishermen so you could get a better, I guess, data from it than working, because a lot of people that are on the marine fisheries have never done that before.
Mm-hmm. I have thought about that, and I think that would be a really good idea moving forward. If we can get, the replacement for that program, I honestly think it would be really good if we could do kind of like a cultural exchange where like we get to go out with some of the crabbers and see how things operate, and they can come and help us even on the trawl survey. So yeah, I mean, that's definitely something I would be interested in seeing.
And we have one more person with their hand up. I'm going to unmute Adrian.
Hey, I had a comment to the gentleman's question about the salinity. Couldn't you overlay that with the the water temps, the historical water temps, to kind of get a better purview of salinity?
Yeah, we could probably we could probably do something similar where we produce those heat maps of salinity and of temperature.
And Matt, just to jump back to both the question from Richard Newman earlier and then that question from Adrian, could you talk a little bit about how the spatial temporal model might account for or implicitly account for environmental variability or differences?
Sorry, can you say that again? I was looking at the comment.
Oh, no, you're good. Could you just talk a little bit about how the spatial temporal model implicitly might account for
Yeah.
some of those differences in environment?
Yeah. So one of the first things we did was try to look at any effect that some of those environmental variables might have on the model, things like temperature and salinity. Um, insofar as we were able to include them in the model, it didn't really change the results. I will say that one of the advantages of that model is they do a really good job in removing the noise that could be coming from a bunch of different sources, including things like temperature and salinity. The other side of that double-edged sword is it can be really hard to determine exactly what is explaining those those changes over space and the interaction between space and time. And so a lot of the times with those kinds of models, when people try to add something like salinity or temperature to explain the variation in the population, it ends up looking the same because those space-time effects just kind of absorb them, which I know is a really unsatisfying way of saying we looked into it, but I still think that we could look at mapping out those effects and seeing how they line up with those estimates of abundance. Thanks for the prompt, Dan.
Yep, and I don't see any other hands, and I think to keep on time, we should probably move on.
Yeah, this next one won't take very long to get through, and so I think we'll still have at least a few minutes for questions at the end. Lauren, I see your comment. Let's get in touch. So the last section here has to do with why we chose the model we did and how it works. So we are using a size-based stock assessment, and I want to talk a bit about what it does. So the population dynamics, think of that big figure I showed you at the beginning with like the population, new animals, growth, death, etc., is set up like this. You have N this year, which is abundance, the number in a given year, is equal to the number from the last year multiplied by the rate at which they survived, S, the probability that they grew, G, plus the number of recruits or new crabs that enter the population. So again, N is abundance, amount of crabs, S is survival from natural and fishing related causes, and R is recruits, the new crabs added to the population. So you're probably thinking, okay, this is pretty simple, and this doesn't sound too different from a model for fish. So the main feature of size-based stock assessment models lies in this G, which is growth, but refers specifically to a growth transition matrix. So remember how I mentioned in the two-stage model, your crab can only be in one of two stages, basically small crab, big crab. In a size structured model, you can get a lot more specific with this. So imagine you have a crab and it's going to grow. We know that crustaceans don't necessarily grow to the same size in a given amount of time. And we also know that females can undergo a terminal molt. So they're not necessarily going to keep growing. They may grow and stop. So the growth transition matrix is a matrix of probabilities that can allow a crab to grow into a bunch of different size classes. Now, of course, if you're a small crab, you have a higher probability of growing into a slightly bigger crab instead of a fully grown crab, right? But you have that kind of spread over all of your size classes. And so we're actually modeling 23 sizes in the model to try and look as closely as possible at growth and survival at that fine of a size of a crab. And so that's why it was built specifically for crustaceans, is because they have this molting process that makes them unique compared to trying to model growth in a fish. And also in most fish stock assessment models, every fish that is, X years old is going to be X years old plus one the next year. And that's not necessarily the case in an animal where growth is a better, or where size is a better accounting of growth than age. So the size-based stock assessment model for blue crab is going to use a size-based stock assessment that was developed by Dr. Jay Chow with Dr. Yang Chen at the University of Maine. Dr. Jay Chow is at North Carolina State University. He was one of the peer reviewers of the 2023 update assessment, and he was my PhD advisor. So I am quite familiar with these methods from my time working with him. I've also got a link here to the paper if you're interested in reading about it. It was originally developed for Gulf of Maine northern shrimp, but has since been applied to a number of different animals, not just crustaceans, but also fin fishes. So it was actually modified by one of my predecessors at North Carolina DMF to assess the spotted sea trout stock. So a similar version of this model was applied to a local fin fish, and the stock assessment report is included in the link here. So the setup for what we call the base model, or basically the reference case, the one we're going to build out from, is going to have 43 years of data from 1982 to 2024, unless we have 2025 data ready within the next, several months or so. 2 seasons, which I explained are January through June and then July through December. And so that's going to be 43 times 2, so 86 time steps over which the population dynamics are measured. Compare this with the last benchmark stock assessment model, which was 1995 to 2016. It's almost triple the amount of time. So we're really trying to get as much information out of the data available as possible. We're only going to have the one fishing fleet to start, which is the commercial potspur hard crabs. Part of the reason for this is because that's where most of the catch that we know of is coming from. And that's going to represent the majority of the population being removed. That being said, we are going to explore some sensitivities if we can get our hands on some other data, one of which is going to be the recreational removals from MRIP. There will technically be 2 indices of relative abundance for surveys, but it's really just the one combined index being split by 2 seasons. And as I said, we're going to look into probably hundreds of alternate model runs to explore other data and how sensitive the model is to the settings. Like I said, I really want to beat this thing to death before it makes it to peer review, because I want to ensure that it passes. Another thing that we've done is we've looked at fitting a bunch of other models out there to the same data to see if it tells us the same story. And so really, we're going to go to peer review really prepared. So what's next? We're still working on testing that base model. I've got preliminary results, but they are exactly that, preliminary, not ready to make conclusions just yet. We've really got to put it through its paces before we can be confident in what it's telling us. Once we do that, we're going to start conducting the sensitivities and look into those other uncertainty diagnostics. After that, we're going to investigate stock status. So once we've done all of this, then we'll start thinking about trying to measure where the population is at in terms of, those overfished conditions. And from there, we'll do projections to see what we would expect the population to do over the next few years after 2024. And so the next blue crab stock assessment meeting that's going to be open to the public is the peer review workshop. I want to stress that, we hit the ground running when we joined DMF, and we've been working hard on this among many other things. We're just about to start the Southern Flounder stock assessment. And again, we're just 2 people, but I really wanted to make sure we take this first step where you are getting an update and a chance to give input before we get to the peer review process. I am interested in making this a more regular thing in the next stock assessment. So I appreciate, everybody's patience in advance for, letting us give this a shot as sort of a midpoint check-in. And so as far as peer review is concerned, we are aiming for this fall. And so what I want to make sure everybody knows is this is not the last chance to talk to us. It's the last time we're going to do a public facing big meeting like this until the peer review, but you are welcome at any time to talk with us directly anytime between now and the peer review for an update. And so to that effect, I do give our emails here at the end. I will put them in the chat for everybody. Please don't hesitate to reach out anytime. I will say that if you want to talk about preliminary results from the stock assessment, I'm going to be really clear that these are not final, but I will be happy to talk with you about them. And so my last bit here is just, do you have any additional specific questions about the stock assessment model? And I'm happy to take questions for the last 4 minutes. And I see in the chat, there is not an assessment app for feedback, but like I said, you are welcome to reach out to me directly, Adrian, and talk to me. We can set up a phone call if you prefer. And then, yes, there will be a recording of this after.
I'm not seeing any hands, or anything in the chat, but we have some time. So if anybody has any additional questions or thoughts for Matt, I see Doug Rader, you have your hand up, so I'm going to unmute you.
Thanks. Yeah, Matt, I just wanted to congratulate the 2 of you and the division for making this investment for all of us and the people of the state of North Carolina, and challenge everyone here to help make sure that resources going forward will take this important beginning and help further it more generally, so that the commissions of the future will have this kind of high quality, cutting edge science to advise the management decisions. And I think it's implicit, but as this process winds down and leads towards a fishery management plan, should it do that, then the more information we can have about all of those other factors that may also be affecting this stock will be critically important. And so, in addition to the sort of salinity and hurricane issues, other things related to predation, right? The relative stock condition of the Albemarle Roanoke striped bass stock, the relative condition, to the extent that we know anything about it, the time course of the blue cat invasion, shall we call it, in Albemarle Sound, the development of the soft crab industry in North Carolina, the development of the competing blue swimming crab markets in North Carolina and the East Coast and the world, and all those kinds of things feeding into the fishery management plan after the stock assessment. So anyway, I just really appreciate the professionalism that you guys are bringing to this process and your willingness to work with people up front. So thank you.
Thanks, Doug.
And we have a question from Glenn Skinner in the room.
Not really a question, just really wanted to thank you for doing this, because as I told you before, we're normally, right when we start management, we're sitting down trying to read a stock assessment and feel like we're playing catch up, and having this information ahead of time and being able to digest it a little bit and ask you all questions before we get to an AC process or an MFC process is invaluable in my opinion. So I just wanted to thank y'all for taking time to do it.
Yeah, thank you for participating, Glenn. I really appreciate it.
And there's a couple other people in the chat that have said thank you as well. So we have a minute left. If there's any last minute questions or thoughts, we'll get to those. Otherwise, we'll call it a night. Matt, I think we're good to go.
Yep. I saw a hand go up.
Oh, all right. We're gonna unmute Mark Mitchum.
Can you hear me?
Yep, we got you.
Yes, sir.
Okay, sorry about that. I appreciate what you're doing. I just think that it's imperative if you're going to have a real stock assessment that real commercial crabbers have got to be involved with in the process, because even among fishermen there are those that catch more than others because that's just the way it is. And when you're taking samples, it's got to be done properly. It could, that's just something. You've got to have commercial fishermen involved to get a real, we know what's going on when we're out there every day crabbing from March through Christmas. I just feel like we kind of know what's going on, and we need to be heard, and our opinions need to count and matter.
I couldn't agree more, and I appreciate you being here tonight.
So I think that should be everything, and we're at 8 o'clock. So Matt, if you're all set, we can call it done.
All right. I just want to say thank you again, everybody who chose to attend tonight. I really appreciate it. I'm really glad to hear from you, and I look forward to working with you more in the future. Hope everybody has a great night.